Hello everybody, today we'll be doing sort, a near sorted or k-sorted array. Given an array of n elements where each element is at most k away from its target position, devise an algorithm that sorts in O of n log k time. For example, let us consider k is equal to 2 and elements at index 7 in the sorted array, which can be at indexes 5, 6, 7, 8, 9 in the given array. So here are some examples. As you can see, the 6 is 3 away from its original position, and the 2 is also 3 away from its original position. So when you think log k, immediately you should think about heaps, and with heaps, we know for sure that it's log k time, because we only have log k items in, and we will be sorting through k items. Actually, in our case, it's going to be 2k, because this is the middle item, and we have 3 items from the left and 3 items from the right. So 2k possibly, depending on the length of the array, but it's an O of n log k time in general. Okay, so we have this and that, these two example cases. This is the last edge case that we're considering, which is empty. Let's just return empty. Are there edge cases like invalid inputs where the k is invalid? Like suppose that's supposed to be like 3 away, but we set it at 1, which is not correct. And that would cause a problem in our algorithm, so we will not handle that, because we expect to solve this particular algorithm where we will get an input that is correct, because there's no way to know that the input is incorrect until we've processed the item and we're like, oh, our algorithm did not work. That means that we have an issue with the input. Okay, so after all that, let's talk about the time and space complexity. Of course, we know already it's n log k time, and O of space-wise, O of log, it's O of k actually, the 2k, but it's essentially k. Okay, because heap, storing items in heap, because each item is seen and it takes log k for popping from heap. Okay, so let's do a match, and we're thinking already heap and loop. So how are we gonna do this? Let's come up with a plan and let's think about it. The plan is that we will iterate 3 items or k items into heap. Then we will loop from 0 to n and pop the smallest item from heap into I index. So that means that we will grab the first 3 items, so 0, 1, 2, 3, so 3 indexed, including k items, including k items. So we have 3 items here, so this is our heap. It's going to be, we're going to have this 2, 3, 5, and 6 somewhere, like so. And now we are going to start at 0 again. So let's build this up. And so our first 0th item is going to be a 2 after we pop this item. And then we will need to add I plus k, which is this particular item here. We'll only add if I plus k is less than the length. While I plus k is less than the length of array, add item to heap. So let's add the item to the heap. Let's add the 8 in. So looks like we have the 8 down here, and now we have a new item. We move the 6 up, and we move the 3 up. And now we have this item. So we move forward. So we have the 5. Of course, this is 5 place. And what happens is that, of course, the first place has been changed to a 2. And now this changes to a 3. And we add a 10 in. So we add a 10 in. We have an 8, we have a 5, right? And now we keep moving along. And next item, we add a 9 in, of course. And we pop the 5. So this is now a 5. And now we remove the 5 from our array, and we have, our stack, and we have a 6. And then we have a 9 here, and then we have 10. It's all good. And now I plus k is out of range. We no longer add I of k. And we take the position at I, and we put in a 6. Then we keep on moving along, and we start popping all the items from our heap. So we have an 8 now on top of our heap. And we move this a spot, put the 8 in, we pop that off. We move to the next spot, we see 9, we pop that off into the 9 spot. And we keep moving along, and we see the last spot, and we pop in the last 10. And when our heap is empty, or it doesn't matter if the heap is empty or not, we just have to go through 0 to the end to pop everything back in. And now we have a sorted array. Isn't that amazing? Okay, so let's implement that plan. And before we do, I'm going to set up the test cases. So I'm going to pause the video, and I'll be back. So hello everybody, we're back, and we have our tests available, and it looks like we got the first case. Let's make sure that's the case. So if not R, then we return the empty array. Okay, so first things first, we need a heap. So that's heapify, heap q, dot heapify, and we're going to grab a item, let's say an empty heap, and set that as our heapify. We want to heapify that. Then what we're going to do is we're going to do our first bit of the plan, which is iterate through k items. So for I in range k plus 1, because we need to include k. So that means that heap, we'll set that as a heap here. So we just drop the items in. Heap.append array at I. So now we've done the first bit. And now we're gonna have the loop. We heapified it. And now let's check if this is actually working, because I don't know if this is, I haven't done heaps in a while, so we're just checking if this is the right. So we need to import heap q first. Import heap q. I don't actually know how to do that, so I'm going to Google it. So yeah, that's exactly how you do it, and that's how you heapify something. Okay, so let's see if that's working. Okay, everything's working well. Great. Let's move on to the next step, because we are ready for that. So next step is we're going to loop from 0 to, for I in range, length of array. We're going to go through the entire length of the array. So if I plus k is less than the length of array, then what we're going to do is heap q dot heap push into the heap our item r at I plus k. Before that, so we need to pop in our answer first. So array at I is going to be equal to heap q dot heap pop of a heap. And we're going to keep, as we said, we're going to keep pushing. We're going to popping and pushing. If this is the case, we can keep pushing. And with that, we should be done with our sort, and we can return the array. So let's run. Looks like there's some problem here. Let's print the array and see what's going on. So we have an issue here. We see that there's duplicates of the first item for some reason. I thought we've popped the item, but it seems to be still in our item. So it looks like what's going on here is I plus k is adding our item. No, that's not right. So what's happening here is that we should have popped the 2 from our heap, but it's not doing that. So let's take a look at what's going on here with the heap, and maybe that'll give us some more information. So the heap looks perfectly fine at this point in time. So let's see where it all goes wrong, which is at this sequence. So we can start printing the array before, and I mean just after the situation, and to see what's going on. So we have a 2 here. I see. So because we stalled the 2 in I plus k, we added the 2 back in. So it's actually I plus k plus 1. That's what we actually want, because we did a k plus 1 here. So we need to do that instead. And now we should have the right answer. See? So a little bit of an error there on my part, because I forgot a k plus 1. But now we are good to go, and we have passed all of our tests. So with that, we have solved the problem, and let's talk about our evaluation after we have done our review already. Evaluation, it's O of n log k, because we used a heap and we iterated through each number to get smallest value. Which is size k. So because getting the item from the heap costs us only log k times, which costs log k. So this costs O of n because every number. I think that's obvious. And the space is k because we used a heap to store 2k items. And that's our evaluation, and that's our code for sort k sorted array. So if you see that we could, make this code better, please inform us how to do that. We'd love to know, and we can all learn together. If you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.